Welcome back to Unit 2, Introduction to Matter, where we're demonstrating how chromatography can be used to separate materials in a solution. By now, you should be ready to compare the results from your lab to the results our students found. So let's get back to the classroom.
At this point, you should be able to see that our three substances were made of more than one colored material. Let's check your results. Were you able to tell that some chemicals traveled further from the center of the filter paper than others?
Well, we found that the red drink mix was made of 3 different colors: red, orange, and yellow.
Which chemical do you think had the largest molecules?
How would you figure that out?
Oh, I know. The larger molecules would get blocked up in the paper, so they wouldn't travel as far.
Oh, so the red chemical must be the largest one because it spread the least.
Great. And how about the candy?
Well, we found that the brown candy and the red candy definitely didn't have the same recipe.
Yeah, they have to be made with 2 different combinations of chemicals because their patterns don't match the chromatogram.
You're right. The different separation distances can be used to identify different chemicals. But for now, you know that chromatography is one important way to find out what solids are dissolved in liquids. Scientists can use these techniques to separate gases as well by using different materials for their filters.
Earlier, you learned about the methods used to separate materials for drinking water, like desalination and distillation. You also examined other methods to separate solids and liquids from mixtures, using your knowledge of physical and chemical properties. You now know how to use density, magnetism, filtration, crystallization, and chromatography to separate materials in solutions. So now's the time when you get to apply everything you've learned in this unit so far to complete an engineering design challenge. So let's get back to our classroom for more information on that.
You all have been given a mixture of chemicals in a plastic bag. You also have a beaker of water. You all have drawing paper, 2 beakers, a hot plate, a glass funnel, Tygon tubing, 6 strong magnets, cheesecloth, a tea strainer, coffee filters, string, rubber bands, paper clips, duct tape, and a ring stand to hold the funnel if needed. Your challenge is to design a method to separate all the components from each other cleanly, using the smallest number of steps possible. Extra credit if you can successfully separate and collect the water from the mixture. You have to use your knowledge of physical properties to separate these materials. Make sure you draw your design on paper and then carry out your procedure.
Hey, the styrofoam will float in water, so let's pour it into the beaker, and then we'll take our cheesecloth over a funnel like this, put it over another beaker, and pour the water in there so it'll catch the styrofoam and anything else.
Okay, let's try that.
All right.
It might be easier if we just poured it through the strainer.
Let's use this pipe to see if we can separate the pieces in the sand.
Yes. We'll need the funnel so that we can pour it through.
Use something to catch it.
Yes, and then we'll need the magnets to catch the iron.
Our students have already given you a couple of ideas for separating these chemicals, but the rest will have to come from you. I'll let you get started, and I'll get started too. When you're done, we'll see you at the top of the last video in this unit.